Hello students, today we are going to handle circle properties. That is always taught in senior 4, though in some schools it is taught in senior 3. Circle properties are set in paper 1. Tunomjisha Lambert is going to take you through this topic of circle properties. So before we go any further, I want us to look at parts of a circle. Consider the circle with center O as shown below. So we have the tangent PQ there, then we have our center O, so we have our radius R, the distance from the point O to any point on the circle, which is the same as the distance from O to the point A. So OA and OB are equal in length, and that is what we call the radius of a circle. So AB, this curved path from A to B, not the straight line but the curved path, which is part of the circumference of the circle from this point A along this curved path up to the point B, is what we call an arc, as you can see in our figure. Now from the point O to the point A along this curved path to the point B and again to O, this O A B, this curved path here that starts from O up to A, then you move along this curved end here back to O, is what we call a sector. Now the line AB, the straight line AB, is what we call the chord. Somebody may ask, what is the difference between a chord and a diameter? The diameter passes through the center. So if I draw a line from this point here through the center O to the other end of the circle, that is what we call the diameter. However, the chord does not pass through the center. It joins any 2 points on the circumference of the circle, not passing through the center, meaning that I can as well draw a line from this point up to this point. That will be a chord. I can draw a line from this point up to this point. That will also be a chord. So a chord connects any 2 points on the circumference of the circle, not passing through its center. Now PQ is called a tangent. A tangent is an external line drawn in such a way that it touches the circumference of a circle at only one point. A tangent does not touch a circle in 2 points. It only touches it at only one point. As you can see, this tangent PQ, the line PQ, touches the circle only at this point here. Now referring to our figure again, this shaded part, this part between the chord and the arc AB, between the chord and the arc AB, this is the chord AB and this is the arc AB. This part here is what we call a segment. The angle theta, this angle at the center, is subtended by this arc AB. When you look at this arc AB, if I connect point A to the center, also connect point B to the center, now this angle formulated theta is the angle subtended by the arc AB to the center of the circle. This can apply to any arc. I can as well draw a line from here up to the center, still from the center up to this point. Now the angle that would be formed here is the angle subtended by the arc at the center, and that is the angle we are calling theta. This angle is going to be very key, especially when we are calculating the areas and the length of the arc. Now the distance from O to A, as earlier said, is called the radius of the circle. The distance from O to B is still called the radius of the circle. How is the radius connected to the diameter? The radius and the diameter are related in such a way that the diameter is twice the radius. So once I know the diameter, it means that I can automatically get the radius. If the diameter of a circle is 10, then it implies that the radius of the circle would be a half times 10, and that would give us 5 centimeters. We proceed. Let us look at some of the formulae that we shall use when we are dealing with circles. Formula number 1 is the circumference of the circle. The distance around the circle, if I am to say the circumference. If I moved from this point of the circle along this path back to this point, that is our circumference, and that one is given as 2 pi r, or we can use pi d. Why do we use d? Because the diameter is basically twice the radius. Area is given as pi r squared. The arc length is given as theta out of 360 times 2 pi r. Now let us first look at the arc length. We are referring to the length from this point along this up to this point B. Now this is our arc. You realize that the arc is part of the circumference, so this arc length from A up to B, this length from A up to B, is given as theta, which is the angle at the center, divided by 360 times the circumference of the circle. Now another component is what we call the sector. So the area of the sector will be given as theta out of 360 times pi r squared. This pi r squared here is the area of the circle. So the sector OAB, this part here, if I want to get the area from O up to A up to B, this area here, the area of this sector, I will simply get this angle theta. I divide it by 360, then times the area of the circle. The segment area will be given as area of sector minus area of triangle. Having talked about that, we can ably apply the formula discussed above in our example number 1. Find the length of an arc which subtends an angle of 126 degrees at the center of a circle of radius 14 centimeters. Find also the length of the major arc. To start with, we need to sketch the circle and include all the information that has been given to us. So we have our angle, which is 126 degrees, that the arc subtends at the center. We have our radius, which is 14 centimeters. So back to the formula. We want to find the length of an arc which subtends an angle of 126 degrees at the center of a circle. We have the angle theta, we have the radius, which is 14. So we simply substitute in the formula the length of an arc equals theta divided by 360 times 2 pi r. Now once we get to this point, the remaining work or the remaining task ahead of us is just substitute. We know our theta as 126. We have our pi as 22 out of 7, and we have the radius provided in the question as 14 centimeters. Now once we run that substitution, you can try out that with your calculator. We should be in position to confirm that the length of the arc will be 30.8 centimeters. The next part of the question, length of the major arc. Now, where is the major arc? The major arc is this. From this point A, when you run along this path up to this point, this is our major arc. Now this point from A up to B, this one here, this length here, is the minor arc. Along this is our minor arc. So if this AB here is the minor arc, then this other part here is the major arc. From this point A up to this point B is what we call the major arc. From this point A on this side here up to this point is what we shall call the minor arc. In this case, we are interested in the major arc, which is the distance or the length from this point up to this point. Now you realize that in our shape or in our figure that we've drawn above, this is 126 degrees, but angles at the center add up to 360 degrees, meaning that the balance of this angle here is going to be got by taking 360 degrees, then we subtract 126 degrees. So we shall take 360 minus 126 divided by 360 times the circumference, which is 2 pi r. So we can substitute that and it will give us 57.2 centimeters. Please verify the accuracy of that answer with your calculator. We should be in position to get 57.2 centimeters. Before we proceed to the next question, what we need to know as far as the length of an arc is concerned, we just need to remember the formula. Theta out of 360 times 2 pi r. Why do we say out of 360? We say out of 360 degrees simply because the angles at the center of a circle add up 360 degrees. So I will simply get this angle that the arc has made at the center. I divide it by 360, then multiply by the circumference of the circle. Question 2. A chord is 8 centimeters away from the center of a circle of radius 17 centimeters. Find the length of the chord, the size of the angle subtended by the chord at the center. So we sketch and put in all the information that has been given to us. As we earlier said, the radius of the circle given in the question so a chord is 8 centimeters from the center. We indicate that. So in this question the chord is here. This is our chord AC. This is our chord AC, and it is at a distance of 8 centimeters from the center of the circle. This is our center O. This is our chord AC at a distance of 8 centimeters from the center of the circle. So we have the radius as 17 what are we interested in? We are interested in the length of the chord. In other words, we are interested in the length or the distance from A up to C. That is our focus on the question. The distance from point A up to point C is what we want. So this distance from the center to the chord here, the 8 centimeters, you realize that this distance from O up to B will be perpendicular to the chord AC. So meaning that this angle here is supposed to be 90 degrees. That is the analysis of the question. That once I draw this from O up to B, this is going to be 90 degrees. An indicator that if this is perpendicular, then BC and AB, A to B, AB will be the same as BC. And since this one is 90 degrees, then in this particular question we can make use of the Pythagoras theorem, because this is 70, this is a right angle, this is 8. We can extract our triangle OBC. So we have O there, we have B, we have C. Put in the dimensions 8, 17. So since this part here has a right angle, there is a right angle at point B, then we can ably use the Pythagoras theorem. So 8 squared plus BC squared should give us 17 squared. So once we run the substitution using the calculator, taking the square root should be in position to get BC as 15 centimeters. Now if BC is 15 centimeters, then AB is also 15 centimeters. An indicator that AC, the distance from A to C, will be the same as AB plus BC. But AB and BC are equal in length, meaning that the length of the chord will be equal to 15 centimeters times 2, and that provides us with 30 centimeters. Now the second part of the question. From triangle OBC, cos theta, you remember from our trigonometry, cos is adjacent over hypotenuse. Our adjacent is 8, our hypotenuse is 17. Now meaning that theta will now be the cos inverse 8 out of 17. When we run that substitution into the calculator, we shall be in position to get theta as 61.9275. So the angle required will now be 2 times 61.9275, and that will give us 123.853 degrees. We can check those answers using our calculators. Proceed. Now, example 3. A chord of length 10 centimeters is 12 centimeters away from the center of the circle. Find the radius of the circle, length of the minor arc, area of the minor sector, area of the minor segment. We can now sketch and put in all the information that has been provided in the question. A sketch always helps us to simplify the interpretation of the question. Much as the sketch may not earn us a mark, but it helps us to summarize whatever has been provided in the question onto the paper. So we can put in that information. So we have our center O. We have our distance, so once we apply the Pythagoras theorem, we realize that 12 squared plus 5 squared will give us R squared. and running the substitution will give us r at 13 centimeters. So the radius of the circle is 13 centimeters. Now to get the angle, we need to get the angle alpha first. From our trigonometry, tan alpha is given as opposite over adjacent. Our opposite is 5, our adjacent is 12. So alpha will be the tan inverse 5 out of 12, and that gives us alpha as 22.6199 degrees. We can check that with our calculators. So the angle at the center will now be 2 times 22.6199 degrees. Now the length of the minor arc, we shall still make use of the formula theta out of 360, but now in this case theta is 45.24 out of the 360 times 2 pi r. So running the substitution will give us the length of the minor arc as 10.269 centimeters. Now area of the minor sector, if I extract that, I have the angle 45.24 degrees, this angle here. I have the radius at 13 centimeters. So I now run the substitution theta, in this case, which is 45.24 out of 360 times pi r squared. Now the r squared is here, this is r times r. So the calculator should be in position to give us 66.74 centimeters squared. So you realize that with the circle properties, the most important part is making a sketch and also running the substitution into the formula. Now area of the minor segment, we can take the sketch. Our radius is 13, our angle 45.24. Now the area we are interested in is actually this shaded area. This area here is what we are interested in. So you realize that to get this area, I will get the area of the sector, the area of the whole of this sector. Then I will subtract the area of this triangle. That will be in position to give me the area of the shaded part. The area of this sector, the whole of this part. Then I subtract the area of this triangle. This will be in position to give me the area of the minor segment, which is the area that I've actually shaded here. So we can now proceed. So the area of the sector minus the area of the triangle, can substitute. Area of the sector will be pi, will be theta out of 360 pi r squared. Now minus the area of the triangle. Now area of this triangle, realize that this triangle is not right angled, but that should not be an issue. We shall use our knowledge of trigonometry, that once I have two sides of a triangle, this side and this side, and I have the angle between the two sides, then it is very easy for me to get the area of this triangle by getting a half times this side times this side times the sine of the angle between these two sides. Let me repeat. Area of a triangle, if I have two sides and the angle between the two sides of the triangle, then we can ably say that the area will be equal to a half times 13 times 13 times the sine of this angle, which is 45.24 degrees. Meaning that if I had this as 18 and this as 20 and maybe this as 60, then the area of the triangle would be a half times 18 times 20 times the sine of this angle, in this case which was I had mentioned as 60 degrees. A half times side times the sine of the angle between the sides. And once we run the substitution, we should be in position to cross check and get our answer as 6.747 centimeters. Please verify this answer using your calculator, because many of the mathematical errors committed by students are a result of inappropriate use of a calculator. You find a student has the right formula, has ably substituted into the formula, but the output of the final answer does not match. Example 4. A sector of a circle of radius 12 centimeters has an angle of 150 degrees at the center. The sector is folded to form a cone. Find the radius of the circular end of the cone. So we can sketch, summarize the information that has been given to us. A sector. Now this is our sector. The angle at the center 150, the radius is 12. So what is going to happen in this question? We have this sector that has been folded to form a cone. So you realize that once you fold this sector to formulate a cone, on folding, this arc length AB will now be the circumference. This arc length AB, once you fold, this arc length AB will now be the circumference of the base of the cone, will be the circumference of the circular end of the cone. Once you fold this AB, once you fold this sector, this arc length AB on folding will now be the length of this arc AB will now be the circumference of the circular end of the cone, and that is the principle that we are going to use. So I can get arc length AB as a theta out of 360 times 2 pi r. So the r is 12 centimeters. Now this gives us 31.4286 centimeters. Now as I said, when you fold, the length, the arc length now becomes the circumference of the circular end of the cone. So when you sketch a cone, this circular end we are talking about, this from this point along this path up to this point, this circular end here, the distance or the length here up to this point will now be equal to this arc length here. So this distance from this point, which is the circumference of this circular end here, up to this, actually we now know this distance here, which is 31.4286, this part here, 31.4286. So this part, since I know this, it means that I can aggregate the radius of this circular end using circumference, which we already have here, the same, will be equal to 2 pi r. So we substitute, and the mathematics will give us the radius as 5.00 centimeters. And that is the end of our question number 4. The most important part, the principle here that we had to apply, is that once you fold this sector, this length of the arc here will now be the circumference of the circular end. So this length from here up to this point, once I fold, it will now be this, the circumference of the circular end of the cone. So we get this length. After we've got this arc length, it will automatically be the circumference here. So, and once I have the circumference, I can easily get the r by making use of this substitution. So, can we now look at example 5? Find the distance between two parallel chords of length 32 centimeters and 24 centimeters, which lie on opposite sides of the center of a circle of radius 20 centimeters. So before we do anything, we need to sketch. Remember what we talked about the chord. The chord runs from one point of the circle to another point minus passing through the center. Once it passes through the center, then that one now becomes the diameter. So the chord must run from one end of the circle to another end minus passing through the center. Should it pass through the center, then it becomes the diameter. We can now take a sketch. To summarize the question, we draw our circle. That is our first chord. That is our second chord. So we have the center of the circle. Now, since the first chord is 32 centimeters, this is 32 centimeters. So I've divided the 32 centimeters into two equal parts, because I said earlier on that once you do a line from the center to this chord here, this is going to be 90 degrees. So if this angle is 90 degrees or is perpendicular, it means that it is going to divide the chord into two equal parts. So the whole distance from this point up to this point is 32. Divide it into two equal parts. We shall end up with this part as 16 and this part as 16. Similarly, we shall apply that on the second chord. It is 24 centimeters, so meaning that once I divide the 24 into 2, I will have 12 from this point up to this point, and I also have 12 from this point up to this point. So now that gives us our real sketch. Now, before we get to the answer, you can see that this angle here is 90 degrees. This is 90 degrees. Now this angle is also 90 degrees. I have this as 16, I have this as 16, I have this as 12, I have this as 12. But we are told that which lie on opposite sides of the center in a circle of radius 20 centimeters. We can put in the radius of the circle, which is 20 centimeters. That is 20, the same as that, 20, 20, 20. So we can now get the distance d1. I can make use of this triangle here, because this is right angled. This is 12. From this point to this point is 12. This is a right angle. From this point up this point is 20. So the 20 here is the longest side, which is the hypotenuse. So we can ably make use of the hypotenuse here. The longest side, which is 20, and this side, which is 12. Now this is right angled at this point, right angled. So meaning that our d1 squared plus 12 squared should give us 20 squared. We can now apply the mathematics to get d1. So shall get d1 as 16 centimeters. Now this same concept will also apply on this triangle. Remember, it is right angled at this. This is right angled here. There is a right angle here. So if this is our 16, this is our 20, then we can ably get d2, still making use of the Pythagoras theorem. So we shall say d2 squared plus 16 squared should give us 20 squared. So d2 will give us 12 centimeters. But what are we interested in? We are interested in the distance from this point here up to this point. Distance from this point up to this point, which you can ably see as d1 plus d2. So once we run the substitution, we shall get 16 centimeters plus 12 centimeters, and that will give us 28 centimeters as the correct answer. Can we now handle example 6? In the circle below, sector OAB has a radius of 7 centimeters and subtends an angle of 120 degrees at its center. So the question, find the shortest distance of the chord AB from the center. Find the perimeter of the shaded segment and also find the area of the shaded segment. Now in this particular question, the sketch was provided for us, so which means that the work to be done should be relatively easier, since the sketch or the figure, the summary of the question has been given to us. Find the shortest distance of the chord AB from the center. Now this is our chord AB. This is our chord AB. Now the shortest distance of the chord AB from the center must be perpendicular to the chord AB. So if I draw a line from the center O here to AB, I can only achieve the shortest distance once this one is perpendicular. So if I draw a line from O up to AB, this one, the shortest distance is that distance that will be perpendicular to the chord. So if I draw a line from O to AB, this is now going to be 90, the shortest distance. Otherwise, if the distance is not the shortest, then it will be longer. It can be drawn up to this point, it can be drawn up to that point. But the shortest distance of the chord AB from the center O to this chord AB should be perpendicular to it, and that is the principle that we must use. So the shortest distance must be perpendicular to the chord. We can now extract that. So where is the 60 coming from? I have this angle which is 120. I divide it into two parts to give me 60 and then also 60. So the sum of this will give me 120. So the shortest distance we are interested in is this, and we've said that it must be perpendicular. So we put in the 7, which is actually here, and that is the distance we are interested in. So since this angle is right angled, this is a right angle here. There is a right angle. So if this is a right angle, this is hypotenuse, this is angle, and this is adjacent. So using our knowledge of trigonometry, the cos of theta is adjacent, of which the adjacent is now d, over the hypotenuse, which is 7. So the cos of 60 degrees will be d, which is the adjacent, divided by the hypotenuse. So cross multiplying, shall be in position to get d as 3.5 centimeters. So find the shortest distance of the chord AB from the center. That is 3.5 centimeters. Part 2. Perimeter of the shaded segment. Now, perimeter of the shaded, this is now the shaded segment. So the perimeter we are interested in, perimeter is the distance around the closed figure. So the perimeter I want of the shaded segment is basically this. I'll get this chord length AB, then I add the arc length here. So I'll get this chord length AB plus the arc length AB. This is what we are interested in, the perimeter, the distance around the chord. So if I'm running around this segment, it means that I will move from A, I'll go to B, then along this back to A. That is the distance we're interested in. So before I get that perimeter, I need to get the length of the chord AB, this length here. is what we are interested in, and you realize that is the same as this, from this point up to this point. That is the length of the chord. So if I get this distance x, which is from this point up to this point, it will be the same distance from this point up to this point. So once I get this distance x, which is actually this distance from this up to here, once I get this distance x, then I will simply multiply it by what? I will simply multiply it by 2 to give me the length of the chord. So sine theta is opposite over hypotenuse. Our opposite is x, our hypotenuse is 7, and that gives us that value, 6.062118 times 2 to give us the length of the chord. So length of the arc AB, we shall use theta out of 360 times 2 pi r, and that gives us 14.667, meaning that the perimeter will now be equal to the length of the chord plus the length of the arc, and that gives us 26.791 centimeters. Now the area, we shall simply use the area of the sector minus the area of the triangle, as we earlier said. So area of the sector, theta out of 360 pi r squared, minus the area of the triangle, where we said that we can have a half times 7 times 7 times the sine of 120 degrees. Where is this one coming from? We said that once we have a triangle with two sides and the angle between the two sides, then the area will be a half times the first side times the second side, now times the sine of the angle between the two sides. Running the substitution into the calculator, we should be in position to verify that the area will be 51.33 minus 21.2176, and that gives us 30.1157 centimeters squared. Example 7. The length of the common chord of two intersecting circles of radius 10 centimeters and 17 centimeters is 6 centimeters. Find the angle subtended by the chord at the center of the two circles, the area common to the two circles. So we start by sketching, and we put in all the information that has been given in the question. So we have two circles. So the first circle has a radius of 10, the second one has a radius of 17. All this is provided in the question. Now the common chord is here. The 6 centimeters we are talking about is from here up to this point. This is what we are interested in. From this point up to this point is the 6 centimeters, the common chord, from this point up to this point. So angle subtended by the chord at the center of the two circles. Now I have this chord. Once I connect this chord to this center, now the angle I'm interested in is this. You can see this is our angle that we are interested in. Once I connect this chord to the center of this circle, now the angle I'm interested in is this. Now those are the two angles that we are interested in. What angle does this chord make at the center of this circle? What angle does this chord make at the center of the other circle? So we are going to consider each triangle separately. So we have the 17. Now the 3 is coming in as a result of dividing this into two equal parts. So I've just drawn a line from this point up to this point. This is actually the line from this point up to this point. So once I draw a line from here up to this, it is actually this. I will now divide this one into two equal parts. So this is 3 centimeters and this is also 3 centimeters. Now this hypotenuse here, as you can see, is 17 centimeters. And we earlier said that once you draw a line from this point here, the center, to the chord, this line is going to be perpendicular. The shortest distance here will be perpendicular. So once I take this, it is going to be perpendicular. Now by being perpendicular to this chord of 6 centimeters means that this side is 3 centimeters, this side is 3 centimeters, which we have ably indicated there. Now at this point we shall apply the knowledge of trigonometry. This is a right angled triangle. Hypotenuse 17, angle alpha is here. So if the angle alpha is here, this is your hypotenuse, this is the angle alpha. This one now becomes the adjacent. This side now becomes the opposite. So in this case, we don't know the adjacent. We shall make use of the opposite and the hypotenuse. And the ratio that connects opposite and hypotenuse is the sine ratio. So we shall say sine alpha is opposite over hypotenuse. Now our opposite, this is hypotenuse, this is angle. This side would be adjacent and this side is the opposite. So sine alpha is opposite, but the opposite is 3 and the hypotenuse is 17. And that will give us alpha as 10.164. So if this alpha is 10.164, now this part also will be alpha. This is going to be alpha. So if this is also alpha, then it means that the angle will now be 10.164 times what? Times 2 to give us 20.328 degrees. Now this same approach we can apply it on the second triangle. Which we can sketch also. Put in all the information that we know. That is our angle theta, that is our 10, 3, 3. So we shall say that the sine of theta, like we did in the first question, the sine of this will be the opposite, which is 3 out of the hypotenuse, which is 10. And theta would be the sine inverse of 3 out of 10, which we can verify. Verify that and confirm if you get the answer as 17.458 degrees, meaning that the angle required will be 17.458 degrees times 2, and that will give us 34.916 degrees. Now the second part of the question, we want the area common to both circles. So we actually need this area, and you realize that I've decided to split the area into two parts. I have area A and area B. So how am I going to get area A? To get area A, you can see this area A. I will simply get the area of this sector, area of this sector, area of this sector, now minus the area. So we have to get the area of this sector minus the area of this triangle. So how do we get the area? So we shall take the whole of this area of the sector, this whole part, the whole of this part, then we shall subtract now the area of the triangle. So which means that we shall get theta out of 360 pi r squared minus a half times r times the sine of our angle, which is 30.6 sine of 20.328 degrees, and that will give us the answer as 1.08944 centimeters squared. Then the area B, we shall still run the same substitution, theta, which is here, out of 360 pi r squared. Now our r is here. So we now get that value as 1.8635 centimeters squared, meaning that the overall area will be area A plus area B, and that gives us our area as 2.95 to 2.9529 centimeters squared. Example 8. Two equal circles of radii 5 centimeters intersect at right angle, meaning that once they meet, the angle formulated between the two radii will be 90 degrees. That will be important when we are sketching. So we take a sketch. There are two circles here of radius. So that is radius 5 and then also 5. So they intersect, the radii will make an angle of 90 degrees. 5, 5, 5, 5. So find the distance between the centers of the two circles. Now since this one is 90 degrees here, this is 90 degrees, this is 5, this is 5, we shall just make use of the Pythagoras theorem to get the value of D. So we shall get our D as the square root of 50, which is 7.0171 centimeters. Now the second part of the question, we make a sketch. So I want that area. So that is 90. You can call that area A, area B, that is the first center, the second center. 5, 5, 5. So since the radii are equal, the angles subtended will also be equal. So area of A will also be equal to area of B. This area here, between this dotted line and this, will be equal to the area between this dotted line and this circle here and this arc. So area B will be equal to 90 out of 360 times pi r squared minus a half times 5 times 5 times sine 90. So and that will give us 19.6429 centimeters squared. Now this is the same area. So the answer there after we've subtracted will be 7.1429 centimeters squared, which you can verify with your calculator. Now this is going to be the same as the area of A, because the radius of A and then the radius of the first circle is equal to the radius of the second circle. So the required area will now be equal to 7.1429 centimeters squared times 2. And that will give us our required area as 14.285 centimeters squared. Now, as far as this particular area question is concerned, or areas, questions of this nature, you just need to be more observant and creative. That if I want this area A, it means that I'm going to get the area of this sector. If I want the area A, it means that I'm going to get the area of this sector here, minus the area of this triangle. If I want the area B, I'm going to get the area of this sector minus the area of this triangle. So area of this sector minus the area of this triangle. So area of this sector here, minus the area of this triangle. That will give us B. Now if I want area A, I'll get the area of this sector minus the area of this triangle. That is the technique that we shall be using under this section. Thank you. We now proceed and have our first exercise. Now all these numbers will require the concepts discussed in the 8 examples above. Make an attempt and do all the 15 numbers. Thank you for listening.
Hello students, I pose a simple question to you. Are you a computer student at O level or A level? Ask yourself, are you good in computer in both theory or computer practical? Either ways, I urge you to look for this book called Direct to Points, Information and Communication Technology, Computer Studies. It has the best notes ever written. Notes in O level. It has summarized notes, questions and answers. It also has a set of UNAMBU questions and answers. But there is another one, also Direct to Points, the Bulldozer. It is known as the Bulldozer. This book can guide you in practicals step by step. It is having a DVD of practical tutorials for free. So go in any nearby bookshop, whether Kampala, Mbale, Tororo, anywhere in the country, and obtain the best book for you. However, some students admire, their dream is to become computer programmers, great computer programmers, but some never make it. They don't become programmers. They even go to universities, but they do not become programmers. It is because of low foundation. How do you build a foundation? Come here and get this small book here called Direct to Points, Elementary Programming and Web Design. You will learn all the foundations of programming. It has also web designing using HTML. Now, it has also a DVD of video tutorials to simplify your learning. Now, what is the essence of this book? For O level, it is part of the syllabus. But if you are at A level, during your vacation, don't hesitate to get this book and practice to prepare yourself a computer programmer. When you join university, you should have the foundation. Else, at the university, they come out, they can't program. They even hire people to do programming for them as a project part. Can you imagine who will employ you when you can't program? So get the book and gain the foundation. Then, if you are at A level, there is also another book for A level called The Examiner's Words. It is Direct to Points, but the book is known as The Examiner's Words for A level or subsidiary ICT 3rd edition. Get that book and enjoy. Mind you, the writers of these books, they won a great Uganda Book Award as a best academic book of the year 2019. So do not undermine these writers. They did a good job to come up with those computer books. Read them with great faith, knowing that you are going to perform. I wish you the best performance and achieve your dream. Do not spoil your future. Work hard as you watch tutorials. Thank you very, very much. Keep on thinking about it. Thank you very much.